Hello everyone, today I am going to deliver a lecture on reaction, shear force bending moment, calculation by force and flexibility method for frame. This is for frame. And first of all, I will try to cover the theory and theory of 3D4 force and flexibility method for frame. Then giving some example of force or flexibility method from frame. So the why we using the force or flexibility method, because we are analyzing the indeterminate structure and finding useful. We are finding the shear force, reaction, bending moment. Okay, so let's see. So this is the Hibbeler book we have been taking here, the force method analysis of frame. The force is used very useful solving problem involving statically indeterminate frames. So you can see here that is the single story and unusual geometry such as a global frame, and the problem solving and multi-story frame is those with the higher degree indeterminacy are best solving use solid deflection or moment distribution or stiffness method discussed in the latter chapter. Okay, so you will notice the following. Okay, so you can see here some examples. Okay, let's see. So how will solve this? So if you go here, then you can see the redundant and use this formula as we have been seeing summation of small s and block letter m. So see here. So you can see here the pin support or hinge support. This is the 2 and this is the 2. So you can see 4. So our equilibrium formula is 3. Equation is 3. 4 minus 3 is 1. So this is the degree of indeterminacy 1. So we cannot solve the virtual work method or unit load method, because this is not determinate structure, because this is the indeterminate structure. So that's why we have to go to the force method. Okay, we can see the redundant number is 1, so we can use the redundant RA. So this is the RA. So this is the pin support. So you can see if we redundant 1, then it will be ruler support. So you can see here, and the redundant one is 1 kip load is given in horizontally, as horizontal load is wood ring here. Okay, so after getting here, so we can take the summation of moment is MD here, and force into 2 into 20, 2 into 15 into 50. This is the load, and 15 divided by 2 in the point load, and RAY is 5, and found RAY is 15. This is the 15, and in this way RDY is 15 also. For this case, we have been seeing one is one unit load is applied horizontally left to right. That's why it will be right to left. Okay, now we are analyzing AB member. This is the member of AB. So analyzing this member, I'm just changing color. This is the member of AB. So AB member we are just cutting here. We're just taking the moment is here. So what will be moment? Moment is 0 as the axial load. The same as it is, we're taking cutting here, the cutting here, and the taking moment is here. M into 1 into x. So it will be x distance, but MAB is 0. Okay, so same CD member. I'm just changing color. This is the CD member. So what is the CD member? This is the CD member. So this is the CD member. So we're cutting the we're taking the moment is here. So we're taking the moment is here, and the axial load. So same as it is for axial load is 0, and taking the moment is also CD is here. So CD member is here, x2 1 into x2, MCD into x2 into 1. So MCD equal to x2. And BC member, we're just changing color here. BC member. So where is the BC member? This is the BC member. So BC member is here. We're just cutting here. So after the cutting here, we just here we can see MBC equal to 2 into, this is the 2 into x3. This is the x3. Just zooming here. This is the x3 and x3 divided by 2, and 15 is axial load is coming here. So you can see the 15 load is also here. It will be comes to here, acting this node or this point, you can say, and 15 into x3, and the final equation will be here. For BC member of this portion, we have been seeing here the one load is here. We're just cutting here x3 into 1 into 10. The 10 is here, the MBC is here. And last one, CB member, BC and CB, it will be acting here. So I'm just which color will take. This is the CB member. The CB means this C, this is B. BC and CB are the same, but the load condition are the different and different location. So this is the load we have been seeing here. Two load MCB into 2 into x4 divided by 2 and 15 into x3, and this is our equation. For this diagram, the CB will be 10 as the 1 into distance into 10. Okay, after getting all this value for analyzing, we will see the M into M1. M means this is the M diagram, we can see, and this is the small m, and this is the big M diagram. Okay, so we are just seeing here that this is the big M diagram and this is the small m diagram. So EI is same, so small m and bigger M and small m, we're just taking AB member, CBT and BC member. Okay, at first we have seen AB member. This is the AB member. I'm just changing color because the AB is red color. So 0 into x1, so it will be 0. If you multiply 0, that will be 0. The CD member, this is the CD member. Just changing color for yellow. CD, this is the CD 0. 0 will be multiplied with someone, that will be also 0. So this will be 0. Okay, so next one, we can see this member BC, which is 15 into x3 into this is the x square minus 15 into 10. This is the BC, and last one CB. We've been seeing here, this is the CB. So CB, all this equation we are taking here and calculating all this value. The limiting value, the limitation 1 in 15. Why? Because the CB is 15, that's why the limiting will be 0 to 15, and putting this value and forming here for deflection A. For FAA means small m into small m, so there is no other issue. This is the small m diagram I have been already shown. We have small m, so that's why small m and AB and CD and BC and CD. So we just multiply double times. So multiply double times x into x minus m into, so minus x double times, and 10 into 10 double times, minus 10 into minus 10 double times. So after putting this value, we are just finding this value. Now this is our final formula, del A minus AB into FA. Putting this value and RB is found here, and this is our answer. After this getting answer, then we will draw the shear force bending moment diagram. But the horizontal displacement is asking here at this is the that's why we are forming horizontal displacement this here, horizontal load. Okay, so RA is founding here. In this case, we've been founding the load. It will be not horizontal displacement, so it will be RA load, reaction, finding the horizontal reaction of the RA. As the question was wrong, determine the reaction of RA of the frame given below. Take this below. Okay, thank you everyone. If you have any question, then let me know. One thing is that the question why I will saying the determine the horizontal determine the force, because this is the force method, so we have to use force method. That means we can use the we just finding the reaction force and shear force and bending moment. If for indeterminate structure, for determinate structure we just using virtual work method, but we are not finding the any forces, just we are just finding the deflection, rotation, like that, not forces. Okay, that's why we've been seeing the deflection, rotation. But in this case we have been seeing here, we have been found reaction, not deflection. So that's why our question was wrong. The determine the reaction at A. It will be the question will be like this, given below. Okay, thank you.